Yo, what's going on, guys? I know it's been a while. Oh man, every time I come here, the nerves, especially when I take a long break. All right, but yeah, what I wanted to talk about today was a Regents question. Um, this is more of like an Algebra 2 question, but this came up as a question in the geometry standard. Well, and I shouldn't be surprised because like I mentioned a lot that in math, a lot of the stuff is just overlapping. Okay, so stuff you'll find in Algebra 2, you'll find in geometry, stuff you find in geometry, you'll find in Algebra 2, even in stats and calculus and stuff like that. Just depends on how in-depth you want to go into it. All right, so yeah, that being said, here I'm going to provide two solutions. The first one's going to be a direct approach, and so without multiple choice. And the second one will be a method where you can use the multiple choice, do some reverse thinking to get the answer. Okay. I personally like number one, but they're both good depending on the yeah, your situation. So yeah. Okay. So look at this question, read over it, pause the video, try it, and then we'll talk about it. Okay, great. So here, a farmer has 64 feet of fence and close this, yada, yada, yada. Okay, so here they're telling you that this farmer has this much length of fence, and they want to uh, find the biggest area using this fence. Okay, so in order to do that, you have to recognize that when they say 64 feet of fence, this is kind of, you have to see what math topic they're referring to. So this is talking about the perimeter. Okay, so basically, um, how much length do they have to work with to enclose something, right? And the perimeter specifically of a rectangle because of this. And this is also another keyword, key term here, biggest area. Okay, so when I hear this in my mind, I'm thinking, ooh, what math topics are coming up? This has to do something with optimization. Okay, so yeah, so this method will be with optimizing this area given these constraints. Okay, so here, if they're saying that the perimeter is 64 and you're talking about a rectangle, that means you can use this equation. 64 is equal to 2L plus 2W, where L and W represent the length and width of your rectangle. Okay, so call that L, call that W. Okay, and then they're saying that the area, you're trying to maximize that, right? So then here we have another equation, area is equal to length times width. Okay, and we know that both of these have to hold, right? And with the extra condition that this A value has to be maximized. Okay, so from here, what you will do is what you could do is you take your first equation and you solve for one of the variables. So I'm going to choose L. I'm going to solve for L in terms of W, and then I'm going to substitute that back into equation 2. Okay, and you'll see why. Okay, so here, let me take this. So 64 is equal to 2L plus 2W. You're going to subtract 2W on both sides. So you get 64 minus 2W, and then you divide by 2 on both sides. So like that. Okay, so you know that divide by 2, go on both terms. So here it's going to be 32 minus W is equal to L. Okay, so this is equivalent to saying L is equal to 32 minus W, but I'm not going to write that here. I'm just going to simply take this, right? So L is equal to this. Okay, so that means I can substitute that back in here, and I'm going to get an equation for W. Okay, so here you can, after you substitute that, equation 2 tells you that A is equal to 32 minus W times W. Okay, and if you look at this carefully, you'll see that this is a quadratic. Okay, quadratic equation with just W. So here, distributing the W, you're going to get 32W minus W squared. Okay. And you might be very comfortable with or more familiar with seeing this as, y is equal to 32x minus x squared. But get comfortable with the other letters, because when you look at this carefully, this is equivalent to this. Okay, so here the way I'm thinking about this, it's an area function that depends on the input W. Okay, so this is good because knowing that this is a quadratic, we know that when you graph a quadratic, you can find the vertex. Okay, and the vertex is special because either the maximum or the minimum can happen here. This is going to be a maximum. Okay, so in order to find the L and W that you want, you can we know that that the maximum area will happen at the vertex. Okay, and so you could do that with Desmos or using your calculator, or you could even do this algebraically using the vertex formula. But here I'm just going to pull up the Desmos and put this in. So we said that area is equal to I'm going to put 32x minus x squared like this. The reason why I'm putting x and y instead of a and w is because I think Desmos natively doesn't recognize a and w as like the regular variables. So you have to like do more work. So yeah. All right. So here it's 32x minus x squared. Okay. But just know that x is like w. Okay. So here you zoom out. Okay. It's quadratic. Okay. And we know that since I said the x is the w, right? So this it's a maximum and this is the vertex. Okay. So it's saying that the x is 16, the y is 256. In other words, the area is 256. That's the max area, and it happens when the width is 16. Okay. All right. So then here that means that area is max when at w is equal to 16. Well, great. So now we know the width. Okay, but if the width is 16 and we said that from this first equation, right, that this has to hold. Oh yeah, so here, yeah, so this has to hold and this is equivalent to saying that the length is this. Then that means we know the length also because it's saying L is equal to 32 minus W. So you substitute the 16 in here and then you're just going to get L is equal to 32 minus 16. And in other words, L is equal to 16. Okay. Hopefully that makes sense. Okay. So in other words, all of this is saying is that the area is maximized. Okay. The maximum area is going to be 256 square units. And it happens when the width is 16 and the length is 16. So the answer choice is going to be 1. Okay. All right. And now method 2. So look over here. I pulled this up from the resource JMap. Very, very useful for those taking the regents. Okay. I'll include a link, okay, to it. All right. And this is the solution that they presented here. Okay. But now let me just explain their method here. Okay. With more detail. Okay. So this is approach 2. So using the choices, the multiple choices, it's a test taking strategy. Okay. So here, what they did is they went through each of these 4 possible scenarios. Okay. They assumed this, and then using this assumption, they found the area for each, and then they, and then the one with the biggest area is the answer choice. Okay. So here, it's this. This piece, I believe, and then this piece, and this piece, and I believe that's the last one. This is choice 4. Okay, this last piece. Okay, we'll go through this. Okay, all right. So let me just show you. All right. So look, what they're saying is, okay. So let's assume that choice 1 is true, right? The length and the width are equal. Well, if the length and the width are equal, that means L is equal to W. And since we're talking about rectangles and the perimeter formula for a rectangle holds, so it's 2L plus 2W. Okay. And here it's saying, okay, so it looks like all the choices are talking about in terms of length. So we should, so we should just substitute this back in here. Okay. So here, if L is equal to W, that means that I can substitute L for W. So then that means that another way of expressing the perimeter in this situation is 2L plus 2L, which is equal to 4L. Okay. The perimeter they said is 64. So this is going to be 64 is equal to 4L, which is equivalent to saying that L is equal to 16. Okay. So we know the length here in this situation. And when the length is 16, you can substitute this back in here, and then you get that the width is also 16. Okay. So W is 16. Okay. Okay, so now we have to find the area in this scenario, right? And the area we know is just length times width. So you multiply 16 and 16, you get that the area for choice 1 is going to be 256. Okay, now we can do the same for choice 2. What does choice 2 say? The length is 2 more than the width. So that means you can convert that into an equation. L is equal to W plus 2. And then you still use the same stuff here. Okay. So if L is equal to W plus 2 and you plug this back in here with the perimeter 64. So 64 is equal to 2L plus 2 times W plus 2. Oh, am I doing that right? No. I'm goofing right now. Sorry, guys. All right, so here, yeah. So L is equal to W plus 2, so you're going to put that in here. Okay. It just depends on which one you want to use. Okay, so 2L and then 2W. Okay, I'm botching this up. Yeah, so here, I'm going to put this as W, okay? So 2 times W plus 2, 2 times W plus 2 plus 2W, okay? So this is equal to 64 is equal to 2W plus 4 plus 2W. You clean that up, you get 64 is equal to 4W plus 4. And then you can solve for W here, and W is going to be equal to 15, okay? All right, so then if W is equal, sorry guys, yeah, this is gonna happen, make mistakes and stuff like that. And scary because it's online, but it's okay, all right? Just go with it. So here it's gonna be W is equal to 15. So now you can plug that back in here because we know that the length is 2 more than that. So that means that L is equal to 17. So 15 plus 2. So that means that in situation 2, when you have that the length is 2 more than the width, then the logic says that the width is 15 and the length is 17, and then you can do 15 times 17, and that's going to give you what is that, 225 plus 30, so what is that, 255. All right, so that's the area here, okay, in choice 2. Okay, so area is equal to 256, area is equal to 255 for situation 2. This is like a close runner-up, but you can see number 1 is bigger so far. Okay, now choice 3. Hopefully we don't botch this up. All right, so 3 is saying the length is 4 more than the width, so that means that L is equal to W plus 4. L is equal to W plus 4, and you run it back in here into this formula. Okay, so this is where I was goofing before. Okay, so I'm going to substitute W plus 4 into L because this is it. Okay, so then this means that, okay, in the perimeter 64 again, so 64 is equal to 2 times W plus 4, right, plus 2W. Okay, and distributing, and you clean this up a bit, you're going to get 2W plus 8 plus 2W, and that's going to give you 64 is equal to 4W plus 8 after you combine like terms. Okay, and then you subtract 8 and divide by 4, and you're going to get what is that, 14. W is equal to 14. Okay, yeah, W is equal to 14. Yeah. Okay. Yeah. So W is equal to 14, and then you substitute this back to get the L. Okay. 14 plus 4, that's 18. So that means that L is equal to 18. Okay. So here's your situation here. Okay. And then you multiply this, and you're gonna get some area. Somebody do the math. Okay. 14 times 18, that's gonna be less than this one, because we know that one's the answer choice. All right. Similarly, you could do that for 4. Okay. And go through that reasoning and compare the areas. Okay. And yeah, we're doing it right so far because they have the work here. Okay, great. All right. Yeah, this is very sloppy, but it's all good. It's all good. Okay. So you'll see this just real time. The main takeaway is just the thought process. Okay. And then as an exercise, I want you guys to try this. Mix these numbers up. Okay. Make this create your own number. Okay. But just be careful. You're sometimes depending on your choice, your number choice, the answer might not be so nice, but the main thing is your reasoning. Okay. All right, guys. That's it. Hopefully you understand, and yeah. Hopefully we'll do more of these Regents questions. Okay. See ya.